Hi. So first of all, sorry for the late upload, but second of all, okay. So remember the days where I made high voltage about the mains voltage with an inverter and an oscillator. But now I want to do really high voltage, rocket high voltage. Not literally, it's a joke. The point is, I want to make high voltage again, but not the pure 200 volts. I get 500, maybe even 1,000 volts. And yes, I had a couple of failed attempts, but this time it's sure to succeed. Let's get on the video. Okay, so here are the parts. So here basically all the parts for the short experiments. So we need a transformer for the super high voltage, the oscillator. This is I think everyone's quite used to this. Who watches my videos. The power supply doesn't have to be huge for the currents on the upper are tiny. And of course a safe place to do it. Prayers I don't die. Please don't make me die. Please. And also that's about it, apart from trying to achieve the gear with high voltage. So let's get to building the circuits. And before I continue, in one of my early videos I pointed out that this is not a good oscillator because first of all it's a toy relay, so at higher current it's gonna burn out, and second of all their sparks will over time wear this out and the moving parts, which will also help with the wearing out of components. But this, first of all, is for a short time arcing machine, and I don't have any other choice, second of all. And third of all, the current of this is not going to be too high, because the current from the output is going to be tremendously low. Still enough to hurt you, but still tremendously low. For higher current applications, for higher current applications, you have to use some special oscillating circuitry, for instance, a circuit driving an IGBT, or even a set of them, for example, like the ones in my inverter video. Please watch it. Anyway, back to the video. This one, that is. Okay, so here's the finished result. So here we have the one of the terminals, positive or negative. The polarity doesn't matter in the circuit because there's no forward, reverse bias diodes or any other polarity dependent circuit, integrated circuit here, which goes to an oscillator, which is the relay coil, which then goes to our transformer primary winding, which then goes to the negative. And by the way, just a disclaimer, this is the low voltage side, and this is the high voltage side, don't get confused. The wire may look thick, but it's not always thick. You have to use a resistance meter to check the resistance with the number of turns. As you can see, the resistance on volts. Resistance of this winding should be high. Well, should be high if the voltage output is going to be high for this transformer. It's not always high though. So it should be higher than the other one. See? It's 1.2 kilo ohms. See? Now for the low wind, for this one, there's two main windings and a center tap, as you shall see now. These two, which I'm using, have a resistance of about 1.6 ohms, nothing much. Now black and white and blue have a resistance of about man, this thing's hard to grip. About 3.3 ohms, and brown is to blue has about 2.3 ohms. So as you can see, black is to brown has the lowest resistance of all, means the highest turns ratio difference of all, means the highest voltage of all, theoretically. Turn the multimeter off, And let's connect the batteries together and turn it on. Let's do it. Speed montage. Now, before I close the circuit for safety reasons, I'm going to remove the circuit from the wooden table, because wood is flammable and arcs can start fires because of the intense heat. So let's move it down to the stone floor, and if I start a fire here, I can burn my lab bench, and then I'm in trouble. Okay, let's do it. The oscillator is working. Let's very carefully move the wire and see if we can make an arc. And of course, let's move our legs away, or else it's gonna be dangerous. Let's get some special pliers as well to move the wire. Okay, let's give it a go. My pliers, well, they're not the most reliable, but they'll do for now. So so the circuit's not on yet. We're gonna grab the wire, and move it close. And of course, we're doing this while the circuit is off for safety reasons. That's failed. Let's unzoom. Let's zoom out, correction. And let's turn on the torch because I can't see a thing. And let's try. You're seeing it's arcing. It's very faint, but you can see it. The circuit will be good for running neon lamps though. You can even see the sparks in the relay coil. But they're very hard to see. This one's a bit easier to see. We're seeing it's arcing a lot. And I don't even need the mains. What a relief. And I'm still alive. We're seeing it's all working. We're not seeing it, but you see that? That small spot. Let's zoom in a bit more. You see it now? Okay, so the video's getting super boring. Let's make it a bit more fun with some actual cool experiments with this circuit. Okay, so I got this broken. It's not broken, it's working. So I got this fluorescent tube from a backlight from a monitor. Rest in peace, monitor. From a broken monitor that Miss Abella gave me. Thank you, Miss Abella. Special thanks to Miss Abella. Special mention, special credit to Miss Abella. Thank you. Anyway, back to the video. So this is a fluorescent tube, and it needs a super high voltage to work like the gases inside the tube, and so they glow, and it produces light energy. Anyway, the high voltage I do not mean 220 volts from the main socket. Not nearly enough. It needs much higher voltages. And let's see if this this setup can provide enough voltage to ignite the gases. And by the way, no, there's no ballast circuit needed because this provides the voltage like those of ballast circuits for it to work. Let's see if it works. For me it's glowing pink, but for you it's glowing white. Let's see. Cool. It's working. And if you observe it's flickering, well at least on my screen it is, but on yours I'm not sure, it's flickering because of the oscillations. Because that's a terrible oscillator. Now it's kind of more constant. Pretty sweet.